Hey everybody, welcome back to the channel. So today we're going to be talking about annular cutters. We're going to talk about, we're going to sharpen one. We're going to go over the 3 different setups required to sharpen one. And then if all goes well, we'll set it up in the mill and we will see if we can't make a hole with this bad boy. Here's the 3 areas we're going to work on. One is the face of this tooth here. We're going to have to deepen this because we're taking material off the end. And there's this inner surface here, which in this one isn't in too bad a shape. But this surface here, this is where the real damage is. It's this corner here that's really going to stop this thing from performing properly. So first we're going to deepen this and minimum skim this face. And to do that face, we're going to want to have, I'll use this to represent hopefully, we're going to want to dial this in this way. So we need to get that right. We also need to get this right, if you're following me. And then there's this angle down in here. We're also going to have to recreate that angle. That angle's there so that it helps direct chips as they're coming off this inner face up through the flutes and doesn't let them go get bunged up in between the plug or the core that's going to remain in here after we sharpen this thing. Today we're using this machine. It's perfectly suited for doing things like these annular cutters. It's again, it's a KO Lee, but this one is a B300 machine. It's not nearly as universal, but it's much lighter, and for doing quick little things, it's just a lot less cranking of handles. And yeah, this is my go-to machine for doing this work. Now, if this thing was in terrible shape, I'm talking teeth broken right off and you know, terrible shape, my first step would be just to cut the entire end off of this thing with a zip disc and thereby saving a lot of grinding. But this isn't so bad. This isn't to the point where we need to do that. We're just gonna give all these surfaces a lick, clean them up, and this will be good as new again. I'm gonna be holding this annular cutter in this sensitive work head. And as it so happens, this tool has 12 teeth on it, and I have an index plate on this work head with 24 divisions, so that's gonna work out just fine. Now this machine is quite a bit less universal than the machine we're normally working on, and so I do have to take more care up front to make sure I'm going to actually be able to get everywhere I need to be. So a little bit more time up front setting up on this machine. Okay, so we've got this surface dialed in here and pretty much 0. Now we're going to move up and down, and we see that that is dialed in as well. So that's 2 of our surfaces dialed in. Now we just have to match. We'll adjust our height with the wheel to match the angle down inside there. And you'll see as I bring them together. And then we'll be ready to go and take a minimum skim off of that face and deepen up that gullet. So we're all set up here. I've got my wheel by eye to the height to match the angle that's in there. It's not super critical as long as there's some angle in there reasonably close to what it started with to evacuate chips. So that's all set up. I've got my dust collector running. So now what I'm going to do, I've already come in to this area. I'll call it a gullet between the teeth. Now I'm going to come out with my cross feed wheel until I can hear it just starting to touch. There we are. And now that will be touching pretty much evenly across that whole surface because we have that dialed in both directions. Now I'm going to start plunging and making this deeper. So what I'm doing is I have this stop set. It's stopping right there right now, and I'm screwing it out. And every time I screw it out a little, I'll go deeper, and I'll just continue doing that until I get to a depth that I'm happy with. So now that I'm at a depth that I think I'm going to be happy with, I guess there's less than a 30-second worth of damage here. So I've gone by eye approximately a 30-second deep. So I'm just going to index to all the other teeth and do the same to them. So there, that was quick and easy. We have deepened this gullet and we've maintained some radius here. It doesn't have to be the same radius, but you definitely would not want a sharp corner there. That could lead to breakage. And if you look at this face, you can see it's nicely cleaned up right from end to end and top to bottom. Moving on to the second of 3 setups now. We are going to set up to grind that inner clearance angle. So I'm putting a different wheel on to do that internal angle, and I'll show you the difference here in a second as soon as I get this off of here. This is the one that we just used. It's got a decent little radius on it, and then on the back side it's got a bit of an angle, and that's what we just used to plunge that gullet deeper. And now to do the internal cutting angle, I'm going to use this wheel. It was a plain style wheel that I've modified into a dish, but it's pretty narrow, pretty pointy down here. I'm going to see if that'll allow me to get right into that corner that I need to. For this next setup, I'm actually going to have to move my sensitive workhead down to the other end of the table. Now, we're doing this as, as an example. For this video, but in a perfect world you'd have like 20 or 30 of these things sitting there on your bench, all needing sharpening at the same time. And after you make each setup, you could run each tool through that setup, and it would really improve efficiency and make it worthwhile to do. So for this next setup, we want to be 12.5 degrees tilted upwards. And we also want to be 12.5 degrees rotated around here. And the last thing that is going to matter as part of this setup is we need one of those tooth faces at centerline height. So we're going to do that, and then we'll be ready to go here. So I've got my angles set. Now I just want to rotate this to center, and I know my head's kind of in the way here. But I have to really get in here and see what I'm doing properly to make this work. So that's where I want that. I'm going to lock that in place. So the trick here is I need to grind that inner clearance angle, and I have to be careful not to nail that tooth that's down below here. And it looks like this wheel's going to work for us. So I'm just going to tighten that wheel on there, and then we'll finish this particular setup. I'm going to set a stop right there, because if I were to go any further, now I don't know if you can see this, but if I were to go any further at all this way, I would be hitting the tooth below the one I'm working on with my wheel, and that would just bugger the whole thing up. So I'm setting a stop right there, so I can't go any farther in that direction. I've got everything in place there now. I have this stop set, so I can't go farther this way than that. And now I'm just going to touch off that tooth face. Now there's a bit of a tail at the back of this tooth face. If you look right here, you'll see there's a little high spot. And when I first came into this, I actually hit that little tail first. But now I'm going to start cleaning up this whole surface. Infeeding a little, and I'm going to take another lap around here because there is quite a bit of damage out here. So I have to bring the transition from the inner angle to the outer angle. I have to bring it quite a bit in this direction, so that as I sharpen and remove this damage from the outer angle, that transition ends up lined up perfectly with this face right here. You'll likely notice I didn't dial this angle in, and the thing is I've just come to learn over the years that the 12.5 by 12.5 is pretty much universal. That's going to work for all the high-speed steel annular cutters that you're going to come across. If this were carbide inlay, it'd be different again, but it's not. So the 12.5 and 12.5 is just about bang on for all high-speed steel annular cutters. I'm getting a tiny bit of heat showing here near the area where I'm grinding, and which is fine and it's pretty normal, but I do want to minimize it, so I'm just going to give this wheel a little lick with this diamond dresser and freshen it up so that it cuts a bit freely and more cool. I'm just going to give it a half a thou, and I'm going to do a real slow finish cleanup pass that'll give me the best possible surface finish. All right, so final setup here. We're going to go 12.5 degrees the other way, and this will put us right where we want to be to clean up our outer surface. But this one's actually going to be tipped up to 15 degrees, not 12.5, and that should give us the perfect transition between the two surfaces. So I don't know how easy this is going to be to see, which tooth I should even point at, but you see basically a line forming here. Well, now we're grinding this outside angle, and we need to bring that line back down here. And what we want the end result to be is that this line is going to come slightly in this direction. So I'm exaggerating right now, but we definitely don't want the line going in this direction. So as soon as I start into it, I'll be able to see if I'm happy with what I'm seeing or if some adjustments need to be made. Again, I'm setting a stop so that I can't travel this way any more than I already am. Again, I would risk nailing the tooth below, and so I want to be careful not to do that. Now I'm just going to take a little minimum skim off this surface, and I'm going to see if I'm happy with the angle of that transition line between the inner and the outer clearance angles. So there, I've just given this surface here a minimum skim. You can still see our damage here, but as this line comes over, we'll be removing that damage. And you can see, I hope you can see, that I'm getting the effect I wanted, where this line will travel towards the back corner, not towards the outer corner, which is, I'm hoping you can see that, but that's what I wanted to see right there. So that's all done. If you take a look in real close here, and it's tough between lighting and glare and everything else, I don't even know for sure what tooth you can see the best. I guess this one's not bad. You can see how it's a little wider across here than it is across here, and that's what I was talking about earlier. I'm hoping I'm explaining that well enough, but that is exactly what I wanted to see. And if we were to go any farther with this angle and move that transition line over any more, then it would work less well than it's going to work now. So this is done. I have a tiny little bit of heat showing. I don't know if that's coming through, but we're going to knock that off with our 2 thou diameter stainless steel wire wheel. These super fine little stainless hairs are going to knock that color and any burr that might be there off, but they'll do it without actually dulling the tool any, which is what we want. And here it is with a little better lighting situation going on, I believe. And you can see all those features. Everything's nicely cleaned up. There's no sign of that damage that we used to have on this outer corner all the way around. That's a nice crisp cutting edge there. And this thing's basically ready to go back to work. Just found a little piece of 12 gauge here that was in my sort of assorted leftover pile here. Just gonna knock some of the burrs off it, and then we'll get it clamped down in the mill, and we'll see if we can pop a hole through it. I figure that speed looks good, nice and slow. I do not know if the motor has the power to do it at such low RPM, but I'm going to start with this. We'll see whether or not it stalls off. So I've got my head as low as I could get it, and I've got my table locked in both directions. My milling head's good and locked up. Everything's as rigid as it could possibly be. So we're just going to see what happens here. A lot of chatter. I'm going to try slowing it down. Now it's really struggling with power. I'm going to increase the feed rate a bit. That should help the chatter. We are really struggling with power here, but it really is cutting like butter. Till it's not.
Whoops.
I'm going to have to increase the RPM just so I have enough power to do this, which is going to make it want to chatter more. So that's probably going to happen anyways. But to combat that, I'm going to increase my feed rate, and maybe that will quiet it down. Fucking gutless piece of fucking... Did I say that?
Very quietly.
All right, so now I'm spinning way faster than I would choose to. It's probably going to make the chatter even worse. And none of this is ideal. But we're here to do it. We're doing it. And we're through. Not the prettiest hole I've ever made, but that's what you get. So I'm going to pop that tool out of there, clean it up, we'll take a look at it, and we'll see how much it did or did not enjoy having to do that. So we're out of the machine now. We've drilled that one hole, and I'm looking all the way around these leading edges for any damage. And you may recall this was really badly damaged over on these edges before, and I'm not seeing any actual signs of wear on that after having chattered through that one hole. So that really didn't work too badly. I suspect we could get many similar holes out of this before it's dull again, even with that chatter. So that's it for today's video, guys. I hope you enjoyed. Maybe you saw something you hadn't seen before. Thanks for watching, and we'll see you guys in the next one.
Bye.